Hi everyone. So in this video, I'm going to be talking about decarboxylation mechanism. As you've heard Professor Pirrung say, for decarboxylation to occur, you need to have a carboxylic acid alpha to carbonyl. So let's go through these molecules on problem 8 and let's determine if they're able to go through the decarboxylation mechanism. Okay, so for the first mechanism, we have a molecule with 2 carboxylic acids. Okay, so now here are the carboxylic acid. So for these, to determine if a molecule will go through decarboxylation, you could reference any of the carbonyls that are in the molecule as your starting point, right? So for this one, I decided to take the carboxylic acid at the bottom. So now let's see if there's a carboxylic acid group alpha to the carbonyl group. All right. So this is the alpha position is this one right here, and as we could see, there is indeed a carboxylic acid group alpha to the carbonyl. So this molecule will indeed go through the decarboxylation mechanism. Okay. So that's carboxylic acid. How about the one after that? Okay. So this molecule, they all have dicarbonyl group. Okay, so it has 2. So let's pick this carbonyl group as a reference, and let's see if there. So this is alpha, this is beta. So as you could see, there is not a carboxylic acid alpha to the carbonyl group. So this one will not go through decarboxylation mechanism and lose CO2. How about the one after that? So let's pick this one as a reference. This is alpha, this is beta. Again, there is no carboxylic acid alpha to the carbonyl, so this will not go through decarboxylation. How about this one right here? So yep, this is carbonyl right here. So we cannot reference this carbonyl because if we reference this if we use this carbonyl as a reference, that means in the alpha position there is no carboxylic acid group. Okay. However, this is important. So however, if we reference this as a carbonyl, there is a carboxylic acid alpha to that carbonyl, so this will indeed go through decarboxylation. How about this one? This one, we reference this as your carbonyl, and alpha to that, you have a carboxylic acid group. Okay, so it's important to have the proper reference. As you can see, if there are 2 carboxylic acid, you could just reference one of them. But if there is a carboxylic acid and a ketone, you must reference the ketone. Okay, so how does this decarboxylation occur? What is the mechanism of it? Okay, let's show it. Let me show you. Okay, so let's pick this ketone right here as our example. So let's draw it. Okay, and you have to draw in a way where you have to have the carboxylic acid part of the carboxylic acid functional group, this one, facing closer to the carbonyl right here. Okay, just like how I drew here. Okay, right, so your carbonyl faces down, but the acid part is closest to the other carbonyl. Okay, so let me just, okay, and the way it works is this pi bond right here will go and grab that proton because it's acidic, right? Once you lose that proton, what happens is the electron that were left will go to make a bond, okay? And now you're gonna break this carbon-carbon bond here, okay? And those electrons will go right there, okay? How does that look like? So if you remember, if we broke the C double bond O on the left here, that means there's a single bond, and you grabbed an H, right? And you made a double bond right here, okay? Plus CO2, okay? So the product is essentially an enol, right? But as you know, as Professor Pirrung mentioned, this is an equilibrium with the ketone, okay? So you end up getting this as a product.